Okay, let's do our Thursday history of math. So I wanted to start off by talking about fractions. So by a fraction, I mean a rational number between 0 and 1. So let's take an example of a fraction. Let's think of 2/9. And so we can represent that in various different ways. So the first way is we can represent it as a decimal fraction, and that's going to be 0.2 repeating. Okay, so let's just quickly figure out how we know that. And I want to put it in the context of kind of like a general base. So let's get out the whiteboard and we want to figure out 2/9. What do? Well, we raise by multiplying by 10. So 2 times 10 is 20. We're going to put 9 into that, and it goes 2 times, and we've got a remainder of 2. Okay, we take that remainder of 2, raise it again, multiply by 10 to get 20, divided by 9, we get 2 and a remainder 2. And so that just goes on and on and on, and that's why 2/9 is 0.2222 going on forever. And so the convention is to put a little dot over the 2 to say that that's repeating. Okay, so if we go back now, let's have a look at base 60. So let's do that computation now. So we've got 2/9. We're going to do base 60. So we're going to raise by 60. So 2 times 60 is 120. And we're going to divide by 9. And that goes 1. 9 into 30 goes 13. Remainder 3. Well, the 3 we raise again. We multiply by 60. 3 times 60 is 180. We divide by 9, and that goes in 20. So we get 1320 is our answer. Okay, so kind of the way that the mathematicians a while ago, they wouldn't have really bothered about saying, whether it was a fraction or not, because the whole thing is, it's kind of like the metric system for us. Like if we see 5 could, as a distance, 5 could be 5 meters, it could be 5 centimeters, it could be 5 kilometers. So in the context, you put the units in and you know how much length it is. So if we're talking in terms of kilometers and we have 5 meters, we would write that as 0.005. Okay. If you're really worried about what the units are, you could write 2/9 as 13 minutes and 20 seconds. And this is kind of more of a later day convention, you can use a sexagesimal point. So we can use a semicolon as a sexagesimal point if you're worried about what the units are. Okay, now here's one that we'll hear about next week, about the ancient Egyptians. Writing it as an Egyptian fraction, it's 1/6 plus 1/18. As we'll hear, the ancient Egyptians didn't write things like 2/9. For them, a fraction was a simple fraction 1 over something. And so you can't have 2/9 because there's only 1/9 of a thing. So they would write 2/9 as a sum of simple fractions, and you can't write it as 1/9 plus 1/9 because there's only 1/9. So how would we go about figuring that? So if we go back to our whiteboard, so what have we got? We got 2/9. This is in 2/9 is over in modern land. So what they would do is they would think, well, if we multiply that by 18, 18, 2/9 of 18 is 4. I can write a 4 as a 3 and a 1. You know, they didn't have any plus signs, so they'd have to do, this is some kind of accounting that an Egyptian scribe would have done, and they would have said, oh, 3/18 and 1/18 are simple fractions because 3/18 is 1/6. So it's 1/6 and 1/18, and they just put like a little line over that to show that it's the simple fraction of a sixth and a simple fraction of an 18th. And so, and this method of the Egyptian fractions was used by the Islamic mathematicians at least till around the 12th century. Nowadays, it's a part of recreational math. But that's how they did represent things. And of course, we could write it as a rational fraction. Rational fractions didn't come about, writing it as 2/9 didn't come about till they had that horizontal bar, and that was an invention of the 12th century. So Al-Hassar, an Islamic mathematician, introduced the horizontal bar in his book, The Book of Demonstration and Reminder. Because it just turns out that fractions are useful things. They turn up, you know, in law when you're trying to share things. They turn up in recipes, all kinds of things. You want to be able to deal with fractions. And so he introduced the horizontal bar, and unlike the decimal point, it stuck. And so from then on, people started writing fractions. A complication. So Al-Hassar preferred to have fractions as simple as possible. So for example, he came up with the idea of related fractions. So for example, if you look at 7/12, you could think of this as 1/2 plus 1/12, and you would write it as a related fraction with that. So you've got 1, 1 in the numerator and 6, 2 in the denominator. And that means, you kind of read it from right to left, it means 1/2 plus 1/6 of 1/2. And so you can think of that as 1 and 1/6 divided by 2. And if you go ahead and put things under a common denominator, you'll see that it's 7/12. So here's an example. So once you start relating two numbers, you can relate 3 or more numbers. So you can have a number like 1, 2, 3 on the numerator, 4, 5, 7 in the denominator, and that represents 69 over 140. And let me show you why that is. Okay, so we've got 1, 2, 3 over 4, 5, 7. So the first thing is it's 3/7 plus 2/5 of 1/7 plus 1/4 of 1/5 of 1/7. And so you can see it's just a exercise now in finding a common denominator. The common denominator, of course, is just going to be all the numbers on the bottom multiplied by each other, and that's going to be 140. And then you just go ahead, the 3/7, you're going to multiply the 3 by 4 by 5. So that's 3 times 20 is 60. You're going to multiply, in the second fraction there, you're going to multiply the 2 by 4, and you're going to get 8. And in the last one there, you just see you have 1. And that's how you get 69 over 140. So maybe more in modern times, the way we would think of this as, so was it 3 and 2 plus 1/4 So it's 3 and 2.25 over 5, all divided by 7. We can see that this is a little bit of a dead end, and it never really kind of took off much. Okay. That's it.